In this activity, our task is simple, although it is not that simple. We're trying to make a conclusion whether x is positive or negative. We're trying to identify where is x positive in these given cases. So the instruction is saying comment about the sign of x in each case of A and B. And we want to look at each case. If you look at case number 1, we've got minus x, and we need to make a conclusion. In which case is x negative in that situation, and all the other cases that follow. Now be careful, you need to understand what do we mean by saying it is negative. We want to know when in this situation is the value of x negative, and that's what we are looking at. And it could just not be, it could be more values of x than just one value of x. Let's get to the first one. In the first case, which is case number 1, we've got x as minus x in the for A, and then x as just x for B. Now, it is quite tempting to think that x is negative here, but what is important is to note that it is the coefficient of x that is negative and not x. So don't make a mistake and say x is negative here. Remember, x is any number, it's a variable, it could be positive or negative, and therefore x itself is not positive or negative, we don't know, but the coefficient of x is negative, and therefore whatever that we put in the place of x here will be multiplied by negative, and if it is negative itself, it will then become positive, and if it is positive, it will become negative. So be careful about that. And when you go to this one, x looks like it's positive, but again, it's the coefficient of x that is positive, it is not x. We do not know the value of x, and therefore cannot conclude that x is positive or negative. The variable x here looks positive, so it's positive x, but the reality is that the value of x itself, we cannot make a conclusion whether it's positive or negative. This second case should maybe illustrate it better for you. You can see now I've got minus 1x, which is the same as what we had before, which was just minus x. So if you look at minus x and minus 1x, it's the same thing. But now how do you then make a conclusion that x is negative here if you did put so in case number 1? So it's minus 1x. Minus 1 is the coefficient, and therefore minus 1 is negative, but we do not know if x is negative or positive. In this case, again, I've equated x to minus 2, so the value of x is very specific now, it's minus 2. So in this case, we can make a conclusion that x is negative because it is assigned to a negative value. So if you thought x was positive in the previous case, now you can see that if I assign it to a negative value, it is negative. Therefore, it had no value before, so it was either positive or negative. Case number 3 is meant to tease your mind and try to push this into your head. Now, if you look at square root of negative x, as you look at it, you can easily make a conclusion that this is undefined because it's a square root of a negative number. But is x minus x a negative number if we don't know what is x? What if x is a negative number? So what if x is negative 4? We're going to have minus 4, which is plus 4. So we can't make a conclusion that this is undefined. We can't make a conclusion that x is positive or negative, as we have discussed already. Similarly here, we do not know if x is positive or negative, and therefore cannot say that this is defined or undefined. We need to know the sign of x, which we don't know at this point. Case number 4 is trying to say, be sure what you are talking about. Be sure if you understand what this whole discussion is about. We've got minus x squared. Now, the question is the value of x negative or positive? Once again, we don't know. In this case, we've got x squared, which has got a coefficient which is negative. We don't know if x is negative or positive. But we do know that if it's x squared that we were talking about, minus x squared is a negative number. So this is a negative number. But we do not know if x is itself positive or negative. On this side, again, x squared is always a positive number. It's 0 or positive number. And if we put a minus 2 here, we will still get a positive number. If we put plus 2, we'll still get a positive number. So we do not know if x is positive or negative, but we know that x squared will be a positive number. It will be either 0 or a positive number. What about case 5? Look at case 5. It says that x is less than 0. And for B, it says x is greater than 0. Now, this is interesting, and I've put it at the end so that it can sort of start our discussion about how do we know if x is positive? How do we write it down? How do we represent it? And you're going to see it's going to answer a lot of questions that you've ever had as we go and discuss this a bit further. X less than 0 says x is negative numbers. Remember, on the number line, any number that is less than 0 is a negative number. And also here, x is greater than 0 means you've got numbers on the right of 0 in the number line, and therefore x is positive. We're going to explore this further because it has got sort of, it's going to give us direction when we start to talk about a number of areas in mathematics, particularly in functions, whether it's trigonometric functions, whether it's parabola and many other functions. But you need to understand that when we say x is negative, either it is assigned to a value, or if it is not assigned to a value, it will be x less than 0, meaning that all numbers that are on the left of 0, which we know are negative on the number line. And here it says x greater than 0, all numbers on the right of 0 in the number line, and those numbers are positive numbers as we know them. We've discussed all the 5 cases. I hope you had fun. I hope you've sort of thought, you've applied your mind again to say, when do we say x is negative and when do we say x is positive? So be careful, look at these cases again, go through the discussion that we've had and try to understand what is happening. And case number 5 is one of the most important cases that I want you to take further as we do our discussions into functions.